The last stop in our journey through Unit 2 in Computer Science A is going to be talking about the math class. So we're going to jump right in, and we're basically just going to be using some methods, some math functions, really. So I created a new class here. It's called Fun with Math, which, is, of course, a bit redundant. But we just need some math methods to call. So what I'm going to do is let's go ahead and figure out what is being expected from me from Computer Science A. And we are going to take a look at the math class here on our Java quick reference. Cool thing that's worth noting is that up to this point now, so we've talked about strings, we've talked about integers, we've talked about doubles. We have not talked about arrays. We've kind of talked about objects, but we are almost all the way through our Java quick reference, and we almost know what everything is on here. So the math class, what it is really a static library is maybe the best way of describing it. What I mean by that, static meaning unchanging. It's not changing. It is what it is. And then library meaning it's really just a set of methods and some constants that we can use. We will at no point in time create a math object, right? There's no instance variables. Math objects, don't really make any sense to make them. All I'm doing is using the methods from the math class. And so the weird thing about that is for us right now, pretty much all the methods we have called up until this point have been called on an object we've created. And so now we got to look at what this means to be calling a static method. So we're just going to use as an example this very first one here. So static int abs, that's absolute value, returns the absolute value of an integer value. All right, so it's called abs and it takes in a value. Great, let's see what that does for us. So here's what it looks like. So if I want to make a new integer x and I want it to contain the absolute value of -42. What I'm going to do is I'm going to call the absolute value method. But what this is what's called a class method, and it's actually called on the class instead of the object. So what it looks like is math.abs, and then what's going to take in is that value that I actually want to do something with, -42 in this case. And so the absolute value method, what it's doing is just storing, or rather not storing, it is stored in the math class, right? And it's just going to convert this -42 to a +42. And so it's called on the class, not on a specific object. So if I print this out, of course, just note out that print line, and then the x variable, hopefully what I should print out, of course, is 42. Oh, no, I'm not using that anymore. Java compile fun with math. Java fun with math. Perfect. 42. Exactly what I wanted. Okay. So I know this is redundant, but I'm going to emphasize it again. Absolute value is a class method. It gets called on the class itself, math.absolute value. And then takes in a value that I'm working with. I do not need to create an object of type math. Okay, and the reason for this, the way that works, the way that does, is because this is what's called a static method. Right? You'll notice all the other methods that we've learned, for example, when we talk about strings, they were called on a string. They are not static methods. Okay, they are sometimes referred to as instance methods. Right? They're called on the instance of an object from that class. And so in this case, they're not called on an instance of an object from that class. They're called on a class itself, and so it is a static method. All right, so we just use absolute value for integers. We also have an absolute value for doubles, which, if you remember, that is called overloading. It has the same name, but depending on what I call it on, it'll return either an integer or a double based on what my parameters are. Okay. Here is another one. It's a power, which you'll notice that it returns a double, and that it takes in a base and an exponent. So, for example, this is useful if I want to find what is the value of math What is 2 to the 5th? All right. Now, if I go and I try and compile this, I'll get an error because what it's going to return is, of course, a double. It's going to return a double, not an integer. Even though I'm feeding it in integers, it's going to return double for me. So if I save that and then I compile and I run, and then I get the number 32.0 because it's a double. All right, and so math.power actually returns that exponent for me, which is nice. And then I've got square root. It's gonna square root the number. I'm not gonna show you. It takes the square root of it. No big deal. And we're gonna spend most of our time here in a second talking about the math.random function, which is super, super useful. Before we do that, let's talk about the fact that, so like how many math functions do you think there are out there? And the answer is, well, a lot. So first off, let's note that there are actually 2 constants here. If you ever want to use the value e, the natural or the base of the natural logarithm, there it is. If you ever want to use the value pi, which is the ratio of the circumference of a circle to its diameter, then I have that there available to me as well. And then, well, here are all my math methods. There are so many of them, which is awesome, right? These are all tools I have available to me. Chances are, if you want to do something mathematical, there is a method that exists for it. You just have to go and find it. So, whole bunch of different versions of absolute value, depending on what the variable that you're feeding into it. Arc cosine, right? So it returns the angle in the range of 0 through pi, is inverse cosine, right? Cosine and sine are going to be found here later as well. I got a bunch of things that you might have never heard of. There was one in here that I saw which was interesting that actually returned to me. I missed it. It was probably called like hypotenuse or something. Yeah, if you give it an x and a y value, it'll tell you. So assuming those are legs of a right triangle, it'll tell you what the hypotenuse is. So essentially returns the square root of x squared plus y squared, which is just like a weird function that exists, but hey, there it is. Logarithms are in here. I already said cosine, sine. Max and min are super useful, or can be, but there's just so many of them. So once again, chances are, 2 degrees, if you want to convert something. So chances are, if there is a function that you are trying to do mathematically, there's probably one that exists. You just have to go and look it up. But these are the ones that we are required to know for computer science A, right, from the College Board. So the last one we need to talk about then is random. It returns a double value greater than or equal to 0, greater than or equal to 0, and then less than 1. Those are important things to note. Less than 1. So let's go ahead and take a look at what this looks like. So if I, so x is equal to math dot random, all right, print it out. What it's going to return for me is a random number in between 0 and 1. 0 inclusive, 1 exclusive. And so I can do this over and over again and get a whole bunch of random numbers. So, I got 0.32, 0.25, 0.40, 0.02, 0.082, 0.82. So it's just a number always in between 0 and 1. Now, what is the probability that I'm actually going to get exactly 0? Well, very, very small. But I could get 0. That is my lower bound. I cannot get 1, though. 1 is out of bounds. It's not actually one of the numbers I can get. Okay? So the question is, how is this useful to me? Well, I'm just generating these random numbers. Like normally, I'm probably going to want to generate, for example, integer values. And so I can do just that by doing a little bit of math on my own. So let's say I want to generate a random number in between 0 and 100. Well, what I can do is, well, I can multiply this by 100. If I multiply this by 100, what happens is that I'm now shifting everything over 2 decimal places, and so I will get, for example, 59.364, whatever, or 27.842, whatever they are. And so if I want to get an integer value, what I can do is my old friend from Unit 1, but I can cast this entire thing to an integer, and I can print this out. And so now this will give me random numbers. Okay, let's think about this for a second. Actually, no, let's run it and then we'll think. Run, then think. Run, then think. All right. All right. Wait, what did I do? Why is it? Oh, it's a double. Okay, I was gonna say that really threw me there for a second. Perfect. Save. Not that that mattered significantly, but it was bothering me. All right. All right, here's a bunch of random numbers. All right, 33, 40, 96, 56, 96, 97, 36. Great. So it's returning these numbers in between, well, actually in between what? That's the question I'm trying to figure out. So what is the lowest number I could potentially get? Well, so what's happening here is that, I'm generating these random numbers in between 0 and 1, 0 inclusive, 1 exclusive, and then shifting them over by 2 decimal places. And so what I can get is I can always get my floor, because what integer does is it rounds down. So I can definitely get 0. It might take me a while, but I could definitely get 0. I am not capable of getting 100 though, because my best case scenario is that math.random is like 0.999999999 whatever until it runs out of digits. When I multiply that by 100, it's going to be 99.999999 until I run out of digits again, which will always get rounded down to 99. So actually I can't get to 100 here. If I wanted to get the numbers in between 0 and 100, well, simple change. I can just multiply by 101. And I can get any number between 0 to 100 inclusive, because now I'm not including 101. Now, let's ask a slightly more interesting question. What if I want to get a specific range of numbers? What if I'm trying to randomly generate a number in between, 30 and 50? Okay, so I want to generate a random number in between 30 and 50. I want to be able to get 30, and I also want to be able to get 50. How do I do that? Highly encourage you, if you want to, pause the video and think about that. Otherwise, I'm going to just jump right in. So what I'm going to do is I'm going to think about the fact that every number is going to start at, has a minimum value of 30. So I'm going to shift up to get to 30. Math.random can, at worst case scenario, be 0. So like that's going to include 30, which is good. And then I want to get, I said between 30 and 50, I think. So how many numbers is that? So I actually want to be able to, if I just did the I don't want to say naive answer, but the simple answer before I think about it too much would be 20. But the issue is that I can only get up to 19 through not 20 times math.random. So I'm only actually going to be able to get up to 49. And so if I want to get all the way up to 50 inclusive, then I have to multiply by 21. Okay, so I can get ranges of values here by manipulating my math.random function and figuring out, whatever adjustment I need to get the range that I actually want. So math.random, definitely probably the most interesting of the methods from the math class that I'm going to be using. However, there are a whole bunch available to me, and chances are if we're doing some calculations, they're going to be useful and helpful. I just got to find the right one that's going to be useful to me in that moment in time. So that's everything I want to know about the math class, last topic in Unit 2. And so this is everything that we kind of need to know right now for objects.